what we're going to do now is create a series of costs which are derived from the ones that we have. We're going to first find ourselves a family of average costs of various kinds. And what you're going to be doing is taking some of the cost functions, call it x, which are always going to be indexed on that volume index that's right there, quantity. And you're going to be dividing them by the quantity itself. And so what you're going to have is it's going to break down to the total amount of this particular kind of cost divided by the quantity, which is going to give you an average of this kind of cost that you have right here. So for example, if we go ahead and put fixed cost in the numerator, and so that's just the fixed cost that's there right away, which doesn't change when the volume index changes, divided by Q, you'll have the fixed cost that's attributable to every single one of the units that you produce. If you go ahead and you take your variable cost, so we'll call it VC, indexed on the quantity divided by Q, what you'll have there is the variable cost per unit of output that you're producing. So again, once you know this definition of what an average cost is, you can generally know what all the other average costs are supposed to be. We could also create a total cost right here like that. So let's go ahead and give you what the shapes of these things are, given the assumptions that we made on our extreme simplifying assumptions about our cost functions. We'll start off with our fixed cost. Now please note that our total costs are shaped like this, with an intercept of being the fixed cost and the variable cost component up here having a slope of alpha. So you can think of it as total cost is equal to fixed plus variable cost divided by, plus variable cost, my mistake. Quantity times alpha. And so there's the definition that we'll have for our costs that we'll be using in class. If you're looking for the average fixed cost, so we'll call that AFC. Just looking for this fixed cost component, right there, the F. You're dividing it by Q. So you're looking at a constant, which is going to be divided by a quantity. You should see that this is a hyperbola. And so you're observing something like this. The quick description is suppose you have a fixed cost of, say, $10, and you're producing 1 unit, you know that your average fixed cost is going to be high. It's going to be $10. But if you have fixed cost of $10 and you're producing 10 units, your average fixed cost is going to be lower. It's going to be $1. If your fixed cost is $10 and you're producing 100 units, it's going to be 1/10 of a cent. So it's a hyperbola, and you're used to saying it this way. The next example that we have is going to be something that's called average variable cost. And what we're doing is taking that variable cost component, which is Q on alpha, and dividing it by Q. And this is, again, our simplifications of costs. Real costs don't look like this. They look like something different. But you're going to find out that average variable cost in our simplified model is just going to be a constant. So for us, it will look like this, always being alpha no matter what the particular volume is. Now, if you were to go up there and create the final cost function, which is known as either average cost or average total cost, one of the two, what you're taking is these two components you've already created and add them together. And so you're taking this fixed component, divided by the quantity, and then what you're doing is adding to it your variable component, dividing it by the quantity. And so your average total cost should look like that, where here is your average variable cost, and your average fixed cost should be the vertical distance between the two. These are roughly the assumptions that we've created out of here, and these are the implications for the average cost, average fixed cost, and average variable cost defined for us. Now, this will allow us to talk a little bit about how bad our assumption is, because our assumption is actually a little on the nasty side. It doesn't fit what is commonly observed about cost functions, and cost functions are not as nearly easy to deal with as you're used to or would be led to believe.